In this lesson, we are going to study about the periodic function and periods of trigonometric function. Firstly, what is periodic function? If we say here, this t value is important because it's going to fundamental period for us. In this fundamental period, the function is getting same value. So if I draw the sine function here, some function is getting graph of the sine function. It's going to be like this. Then here from this point to this point, it's going to be 0 to 2 pi, and it's going to repeat after 2 pi, it's going to repeat the graph again. So this graph, when you move this graph here, you are going to see that this graph and this graph, it's going to be the same. So this is the period of the function, where it's get the same values. Here it's getting 0, then here it's going to get 0, something like that. Okay, we are going to understand with the examples better. For the trigonometric functions, sine and cosine values, they are getting in 2 pi units same value. If you remember from the unit circle, sine and cosine values, they are getting same value in 2 pi period. And tangent and cotangent values, they are getting the same value in pi period. So the fundamental period of tangent and cotangent is pi. Fundamental period of sine and cosine is going to be 2 pi. If we solve some questions about these are, for cosine 2 times cosine 3x, we are going to solve the question. 2 times cosine 3x, we are going to use the formula also at the same time. Fx is equal to fx plus t to find the fundamental period here. And at the same time, we know that cosine x is equal to cosine x plus 2 pi k from the reduction formulas. How was the reduction formulas? If you remember, 2 pi plus alpha is equal to, in the first quadrant, 2 pi you're using, you're not going to change the function. Cosine alpha, it's going to be, in another word, cosine alpha is going to be equal to cosine alpha plus 2 pi k. It can be here how it is written also, and this k is showing the number of turns around the unit circle, so that's why the k value, it's not exactly important for the alpha value. And here cosine 3x, we are going to solve the cosine solution for the question for the 3x. Cosine 3x with respect to this information, it's going to be equal to cosine 3x plus 2 pi k is going to be okay. Then if we apply the formula here, fx is equal to 2 times cosine 3x is equal to 2 times cosine 3 times x plus t, it's going to be. So this 2 and this 2, if we simplify, cosine 3x is going to be equal to cosine 3x plus 3t is going to be, if we distribute the values. Now I'm going to find the cosine 3x, and cosine 3x, I'm going to replace here cosine 3x by cosine 3x plus 2 pi k. Cosine 3x plus 2 pi k is going to be equal to cosine 3x plus 3t. If you continue to this one, 3x and 3x plus 2 pi k is going to be equal to 3x plus 3t. So 3x and 3x, if we simplify, 2 pi k is going to be equal to 3t. So 2 pi k over 3 is going to be equal to t. So fundamental period for this function is going to be 2 pi k over 3. Okay, now we are going to solve the similar question for 2x. And as you understand here, sine x is equal to sine x plus 2 pi k. So sine 2x at the same time, this is special for also trigonometric functions. Sine 2x plus 2k pi, it's going to be. The definition of fundamental period of for the functions, the definition is fx is equal to fx plus t. It should be, pardon, not pi, t, it should be fx plus t. Then 3 times sine 2x is going to be equal to 3 times sine 2x plus 2t. Here I distribute indirectly, but let me go step by step. Then x plus t is going to be, okay, then 3 and 3 you may simplify, and we have sine 2x. Sine 2x is equal to sine 2x plus 2t. Okay, then here sine 2x is equal to, at the same time, sine 2x plus 2k pi, and that's equal to sine 2x plus 2t. This should be in parentheses, by the way. It means that 2x plus 2k pi is equal to 2x plus 2t. So 2x and 2x on the both sides we can simplify. 2k pi is equal to 2t. 2 and 2 you may simplify. Pi times k, or k times pi, it's going to be our fundamental period. For tangent 5 times tangent 7x, we are going to apply the same formula again. Fx is equal to fx plus t, it's going to be. So 5 times tangent 7x is going to be equal to 5 times tangent 7 times x plus t is going to be. Here tangent 7x is going to be equal to tangent x plus 7x plus k times pi at the same time. So I can replace the 7x by here 7x plus k pi. Here these two, when we simplify, tangent 7x will left, and tangent 7x is equal to tangent 7x plus k times pi is equal to tangent 7x plus 7t is going to be. So 7x plus k times pi is going to be equal to 7x plus 7t. And when you simplify this two, k times pi is going to be equal to 7 times t, and k times pi over 7 is going to be equal to p. So fundamental period of the tangent 7x function is k times pi over 7 is going to be. Here is the summary of all these formulas we have. For sine ax, cosine ax, tangent ax, and cotangent ax, what is the fundamental period? T is going to be equal to, as you see here, t is going to be equal to, for sine and cosine, 2 pi over absolute value of a. For tangent and cotangent, pi over a it's going to be.